Watson here, and in this video we're going to be talking about the conduction system. So the conduction system, so we know about the pathway of blood, but we need to know what helps contract this blood out. How does it happen? So the conduction system is going to give us some understanding of that, and we're also going to get some understanding of the cardiac cycle and how they all link together. So the first thing we need to know is that the heart is myogenic. So what that means, it has the capacity to generate its own electric impulses. Okay, so you might have got that from the name, conduction system, conduct electricity, own electric impulses. So we are conducting impulses here. So myogenic, the characteristic of the heart, means its function is it can generate its own electric impulses. So before we learn the system, let's take a look at the key parts of the conduction system. And the first one, we have the SA node, the sinoatrial node, okay? And this is known as the pacemaker. This is the one that generates these impulses I just mentioned, and these impulses will travel through and contract the atria walls. Okay, so this is what will get the atria walls to contract. Okay, that's this SA node. But once this node generates these impulses and wants to send it through the walls, something needs to pick it up. And that's the AV node, the atrioventricular. So we've heard of the atrioventricular valve, but this is the AV node. Okay, and it's almost close to the center of all four chambers, but this AV node around the atrium and ventricles, okay, this collects the impulse and delays it 0.1 seconds. Basically, it's allowing the atria to finish contracting. Once it collects the impulse, it releases it again, and we have the bundle of His. This basically splits the impulse into two. Basically one for each ventricle. So that's why you'll see on the diagram there, you've got what are called bundle branches. There's two of them. And there's all that means, so we have two ventricles, we have Purkinje fibers in the walls of each ventricle. And these Purkinje fibers pick up the impulse, which started all the way back at the SA node. And it distributes this impulse through the ventricle walls and causes them to contract. Okay, let's try and have a look at that in an animation I made. There are some on the internet, but I've tried to make my own so you can see it a little bit slower. So here's the SA node. The SA node is going to generate its own impulse and fire it through the atria walls. Then four pathways right there. So it's not forgetting about the left atrium. This causes the atria to contract, and the AV node, which has just picked up that impulse, delays the impulse 0.1 second to allow that contraction to finish. It's then going to pass the impulse down to the bundle of His. The bundle of His splits the impulse down two bundle branches. The Purkinje fibers get the impulse and distribute it through the ventricle walls, causing the ventricles to contract and forcing that blood out through the pulmonary valve and the aortic valve. Okay, so that's how the conduction system works. So four key parts there. Now we have the cardiac cycle, and then we're going to link these back together. Now, before I go into the phases of a cardiac cycle, diastole and systole, we need to understand some principles about blood flow. Blood flows from high pressure to low pressure. So as the atria are filling, the pressure increases because they're now filling with blood. There's more pressure in there. Now, as that happens, the AV valves, the tricuspid and bicuspid, I'll just refer to them as AV because it's easier to reference both of them. The AV valves open naturally and blood starts to flow to low pressure. So in this case, the lower pressure is in the ventricle. So you can see the filling there, and there we have the low pressure. So blood flows from high pressure to low pressure. So once the atria are filling, blood needs to flow to low pressure. So these valves open naturally and the blood enters the ventricles passively. But just for now, understand the principle. Blood flows from high pressure to low pressure. Second principle, contraction increases the pressure. So when the SA node generates its impulse and fires it through the atria walls, it causes the atria to contract. And if you can see there, they're changing shape. And the blood is being forced into the ventricles. So the pressure is being increased due to contraction. It was already high anyway, but it's now increasing the pressure further to get it to the low pressure. Okay? But once the ventricles get that pressure from the valves, the pressure is going to change. So we're now going to focus on the valves. So the valves open according to the pressure gradient. So initially, the atria were just filling and the valves open naturally, just because they want to allow blood to flow. But once that contraction happened and increased the pressure, it forces the valves open. And by forcing the rest of that blood from the atria to the ventricles now have most of the blood. And the pressure gradient is going to change. So we look, contraction is going to force it open. Okay, watch when the contract, when it changes shape, it forces open. But the pressure gradient is now going to change. Now look at the reverse. Once the pressure gradient's changed, the valve is closing. And if we remember, why does a valve close? To prevent the backflow. The pressure gradient's changed. So now this valve's closed to not let it go back. It must flow in this direction. So now the ventricles have the highest amount of pressure. So we go back to principle number 1. Blood must flow from high pressure to low pressure. Now the next area of low pressure is in the pulmonary artery. So the blood is going to flow from the ventricle as the ventricle contracts through the pulmonary valve, and you can see this valve opens. Valve opens, and the blood will flow from high pressure to low pressure. Now, once the ventricles finish contracting and most of the blood is in the pulmonary artery, then the pulmonary valve will close because we don't want backflow. Okay, so there's some principles to understand. And if we just look here, as we mentioned, dual pump. One complete cardiac cycle represents a single heartbeat. So there you can see dual pump. Okay, changes in pressure. So there's just some principles, and now we're going to move on to the cardiac cycle phases. 2 phases we need to know here. Diastole being first. This is when the heart relaxes and fills. Not the only time it fills, because the ventricles also fill during systole, which we'll come on to, but this is where all 4 chambers are relaxed. So firstly, the atria will fill with blood, and then as pressure gets higher, the valve will just open naturally and the blood will passively enter the ventricles. So the relaxation of the heart is the diastole phase. First the atria relax, then the ventricles, and they fill with blood. Meaning we have systole, which is the contraction of the cardiac muscle. Firstly the atria, so atria contract, force the rest of that blood into the ventricles, and then the ventricles contract and force the blood into the pulmonary artery and the aorta. Okay. At rest, one of these cycles takes 0.8 seconds. Okay, which gives us our 70 to 72 beats per minute at rest. Okay. So here is the 2 phases. Diastole, the relaxation. Systole, the contraction. So now let's look at how this works in a cycle. First up, we have atrial diastole. The atria will fill first. We've just mentioned that. Once the pressure gets high in the atria, the blood will passively enter the ventricles and the ventricles will fill. So we have two phases of diastole here, atrial and ventricular. Okay, so the atria starts filling with blood. AV valves open because we have a pressure increase. Blood must flow high pressure to low pressure. And that they enter the ventricles passively. But as we know, the SA node is about to generate an impulse. And when that happens is, the ventricles will stay in diastole, they will continue to fill, but it will happen under atrial systole. The atria will change shape, the walls will contract and force that blood into the ventricles. Okay, so the atria contract, forcing the remaining blood. And that will, once that systole is finished, that completes our ventricular diastole, and we move on to the second phase, which is ventricular systole, the contraction of the ventricles. Okay, so ventricles contract, they increase their pressure, which means the AV valves close because we do not want backflow, but the semilunar valves open. They are forced open and blood ejects from the ventricles into the aorta and the pulmonary artery. As we know, ventricles are discharging chambers. They eject blood and they do it forcefully through systole, contraction of the heart. Okay. Now, this is one way to look at it, but I'm going to show you it in a different, because its name is a cycle. This is never ending. So we're going to look at it a little bit differently. Okay, this might look complicated, but hopefully it's quite easy to understand. We're going to start here. Atrial systole. Now, as you'll see in this segment, we have 0.1 seconds. Well, that makes sense because the AV node delays it 0.1 second because the atrial systole needs to happen, which is basically the node waiting for contraction to finish. So atrial systole, and as soon as systole is finished, it's into diastole. There's no break. It's systole, diastole. Ba-boom, ba-boom. Okay? So once it's contracted the blood into the ventricles, it starts filling again. And as you'll see there, it's already filling while the ventricles are in systole. So here we have ventricular systole. And if you look at this cycle, as that's happening, the atria were already filling, which means as soon as the ventricles force that blood out the valves, they're already starting to take blood passively. Because we know the only time it receives blood forcefully is that overlap there during atrial systole. Okay, so this cycle just goes on and on. Okay, when it's not in systole, it's in diastole. Systole, the contraction; diastole, the relaxation. Okay, so I hope that breaks it down and makes it a little bit easier to understand. But to finish up, I'd like to link this for us. Conduction system and cardiac cell. We're going to link them together. So, conduction. No electrical impulse. Now, if we know electrical impulses cause contraction, that means there is no impulse. That means the heart must be relaxing. Diastole. So when there's no impulse, it causes diastole. It causes the heart to relax. Now, in the event of the cardiac muscle relaxing, what happens? Well, the SL valves close because the pulmonary artery and aorta are now taking the blood to the lungs and the muscles, so we don't want backflow, so they'll close and the atria will fill with blood and the AV valves will open and blood will passively enter the ventricles. There's no contraction here, so the blood passively enters. Now, let's look at the next stage. The SA node generates an impulse and fires this impulse through the atrial walls to the AV node. The AV node delays the impulse. We know that 0.1 second because that's how long atrial systole contracts. But when the SA node fires it through the walls, it causes atrial systole. It causes them to change shape. The event is the atrial muscles contract. That means them walls are going to change shape and force blood into the ventricles. So the effect here, the AV valves, they were open allowing passive blood, but now they're forced open and blood is pushed into the ventricles until the atria finishes contracting 0.1 seconds. So here we go. SA node generates an impulse, fires it through the atria walls to the AV node. That causes contraction and the blood going into the ventricles. Okay. So then we have one more phase. The pressure is now higher in the ventricles. Okay. But now we need the blood to leave the ventricle because it must go to lower pressure. So what happens is the bundle of His splits the impulse into two down the bundle branches and the Purkinje fibers distribute it in the ventricle walls. Ventricular systole is the cause of that conduction. What's the event? The ventricular muscle contracts. It forces that blood out. So the effect is the AV valves this time, they close to prevent backflow. We've had a change in pressure gradient. The gradient is now lower in the atria. So we need to send it to the next low place, which is the pulmonary artery or the aorta, because we don't want backflow. So we force the SL valves open and the ventricles push the blood out. So from the AV node to the bundle of His branches and the Purkinje fibers distributed, the ventricles contract and push that blood out, force the semilunar valves open, and then the aorta and the pulmonary valve will take the blood to the body and the lungs, and now they have the high pressure and the SL valves close again to not prevent backflow, and we just go back around the cycle. Okay, so that was the conduction system linked with the cardiac cycle, and as you can see there, we also have the pathway of blood. So that's just linking it all together. Try to do a few animations to help you visualize what's going on, but you can pretty much get the whole idea from it from these last three summary slides. But I'd suggest watching the whole video for this one to have a good understanding. Okay, hope it helps. Thank you.